Hello and welcome to our discussion of nebula and galaxies. This will just be a brief overview of what is a fairly complicated topic, as you might have guessed, many stages during this course. It's worth pointing out that there's always more detail to be sussed out in many of these topics, and we're really just touching the tip of the iceberg here. Nebula and galaxies, we're going to focus on classification and description. So what is a nebula? Well, it's a mixture of gas and ice and rock and dust that's out there in space. It's amorphous. It's usually kind of how do you say it? Nebulous. Okay, it doesn't have a good shape to it. And there are a few different kinds. How big can they be? Well, we're talking about different kinds of nebula, but we're looking at light years to hundreds of light years across. And so they cover vast regions of space. They contain many solar masses, so 100 to maybe 10,000 or so solar masses. Much bigger than our star in terms of the amount of material that's in there, but they have a pressure, a vapor pressure or a vacuum pressure that is 13 to 18 times less dense. Okay, or orders of magnitude, 13 to 18 times orders of magnitude less dense than the Earth's atmosphere. This means we're moving that zero or the decimal place, 13 to 18 positions to our left on any kind of integer, and so we're looking at something which is a vacuum, basically the vacuum of space in which we cannot produce on Earth. If we took a nebula and there was basically like the density of the gas was the size of the Earth, it would just weigh a few kilograms or tens of kilograms because there is not much mass there. There are a few different kinds. I'll show you two that are pretty common. The emission nebula, which is red, and the reflection nebula, which is blue. There's also a kind of dark nebula. So you can see here the emission nebula on the left-hand side. Notice the color here. It's bright. It's light colored in certain areas. It's got a lot of red colors or streaks coming off of it. It doesn't have much of a shape to it. Okay. But this is presumably hot, okay? So it's emitting light because it's hot, and it is a good place for stars to be forming in the emission nebula. The scale here is 1 to, or even less than 1 to 100 light years across, and solar masses would be around 100 to 10,000 solar masses. So a lot of material there. On the right-hand side, you see a relatively small nebula, okay, but it's a planetary nebula that's related to the explosion or the off-gassing of an average-sized star similar to the Earth, right? So this is a kind of potential supernova, or in some cases, in this case, it's just gases that are expelled from the core, from the radiative zone and the convective zone, leaving behind the core of this star, which ends up to be becoming a neutron star in this case, okay, or a white dwarf if it's the size of our planet, of our sun. Okay. Other kinds of nebula, we have reflection nebula here on the right-hand side. What are we seeing there? We're really seeing light that we interpret to be reflected from ice. So this nebula is cooler. Okay, it's not being agitated by the proximity of a star necessarily, and so the blue color is related to ice in the system. And then over here on the left-hand side, you'll see this black spot that sits on the field of stars and galaxies behind it. Small versions of these would be 3 light years across. Okay, strong absorption of light, mainly dust and rock. So this is a slightly denser and more compact object that's good place for star formation to occur, because we've got a dense collection of material to collapse. Okay, so if we just back up, we've got a Mission Nebula, which is fairly common. We have Planetary Nebula, which is relatively small. We have Dark Nebula, which is absorbing a lot of light that's not really able to escape because it's so densely, or much more densely packed in there, and is a good place for star formation, potentially. And then we have Reflection Nebula, which tells us something about the composition. The blue color tells us a little bit about the composition. We're getting this blue polarized light. Okay. If we jump to galaxies, we can start off with our galaxy. And one of the things that I think is relevant when we're talking about galaxies and classifying them, are just three basic types of galaxies to think about. But is the scale of a galaxy, okay, in terms of light years. So let's just take the Milky Way, which is a galaxy we're living in. You can see here 200,000 light years across, okay, and we're existing kind of way out here somewhere in one of these spiral arms of the galaxy. Let's compare that to the scale of the solar system. The solar system is not a light year, okay, but it's just a few light minutes. And so from the sun to the Earth, which is 150, on average, 150 million kilometers, right? One astronomical unit. It's just 8 light minutes. Okay. The Milky Way itself, we believe, is a barred spiral galaxy, and it contains on the order of a few billion stars, 200 billion stars, which is quite a few, quite a few stars. So you go back to our Hertzsprung-Russell diagram, total number of stars drawn on that diagram, I don't know, 25 stars or something like this, 30 stars. So obviously we can create a diagram that's much more densely populated. On the top right, you'll actually see a kind of rendition of what the Milky Way looks like. What's interesting to think about here, you can see the spiral arms coming off. You can see a central bulge, which is a little cooler zone. Okay, so star formation, so the older stars are going to be sort of in here in the center. We will find presumably a super big black hole holding the whole thing together. And then the younger stars are out here forming in these spiral arms, which are a little bit brighter and bluer. Okay? Now, this rendition, because we live in this galaxy, we actually cannot image it in this way. And I want you to think about why that is just for a second. We cannot image our own galaxy from a sort of top-down view. It's because we've only just sent something out of the solar system, right? Nothing's left the galaxy. We're not intergalactic or between galaxies. There's nothing out there for us to actually take a picture of. So all of our pictures will be from within the galaxy. We can, of course, plot positions of objects. And so every image we see of the Milky Way is an artist's rendition of that, okay? There are a couple different kinds of galaxies, and they have different behaviors, different compositions, and they form presumably in different ways. The elliptical galaxy here is one type of galaxy. It tends to be one of the larger types of galaxies, 300 million light years across, and typically contains trillions of stars. Okay. There may be several varieties of these, okay? But for right now, we're just going to use this as one classification. So much bigger and more populated with stars. Okay? They tend to be older and a little bit cooler. Okay? The spiral galaxy here On the left-hand side, you can see the arms coming off here and here, radiating from a central bulge. So you'll notice there's no real central bulge. There are no arms in the elliptical galaxy. It's just a kind of oval shape with a diffuse distribution of light coming off of it. No light and dark zones or arms. So the spiral is another classification, broad classification of galaxy. And then a subclass, okay, of galaxy is the bar spiral. Okay, you can see here we've got a central bulge again. We've got some kind of black hole, super black hole in the center holding everything together. And then off comes one arm and off comes a second arm right there. Okay, so spiral, and then we have bar spiral, which is related to the spiral. And then the last one is the irregular galaxy. And the irregular galaxy, you'll notice, is a good place for lots of light, lots of star formation. All of these areas that are super bright we interpret to be areas where stars are forming. The irregular galaxy is presumably a galaxy that's been perturbed or represents a couple galaxies that have actually collided and have come together. And it's these types of events that are very productive, we think, in terms of creating stars. So spiral, irregular, and elliptical are the three main types of galaxies. How big are these? They tend to be on the small side, 20,000 light years or so across. So not nearly as big as the spiral galaxies. Okay, here's our Milky Way. You can see here it looks to be, as we interpret it, probably a kind of bar spiral galaxy with arms that many of them have been named. Some of those things are obscured here. Hey, is this a real photograph? Well, no, we know it's not now. All right, so that summarizes nebula and galaxies. Just one more section before we get to the end, and we'll talk about just the evolution of the universe.